about related rates. And for the acronym to remember related rates is DREDS. So the first step in DREDS is D, which is diagram. And when you diagram, you're going to draw a picture of all the information you're given, and you're going to assign variables. And then the R is related rates. The R is related in related rates. You're going to write down all the known and unknown variables. So for example, if you're given a data, and if you're given a theta dt, you would write down all the, and you try to find dht. And for E, it's the equation. And in the equation, you're going to write down an equation to express the information you're given. So for example, if you're trying to find area, then your equation could be A equals pi r squared. And continue with the area model. The other D is differentiate. So you differentiate the area equation, and that would be the ADT equals 2 pi r dr dt. And then the last step is to substitute, and you're going to substitute in all the related rates that you found you're going to substitute in all the related rates you found into the differentiated equation. And now here's London, who is going to do an example of how to do DREDS.
A hot air balloon is rising straight from the level field and is tracked by a rangefinder 500 feet from the liftoff point. At the moment the rangefinder's elevation angle is pi over 4, the angle is increasing at a rate of 0.14 radians per minute. How fast is the balloon rising at the movement? An example 1. For the diagram, going based off the DREDS, the step 1 is diagram. So we drew a point where the rangefinder is 500 feet away from the liftoff point, and the balloon is at the top. This shows H, and this angle here, pi over 4, is theta. So the second step in DREDS is related rates. So from the equation we found out we needed to find dht, but we were also provided with the theta dt, which is 14 radians, and theta, which is pi over 4. Step 3 of DREDS is equations. So we have to find dht, we have to find h. To find h, we did tangent, because we have adjacent and opposite. So h over 500 equals tangent theta. So h equals 500 tangent theta. The fourth step of the DREDS is the D. The D. Can you hold that up?
The D stands for differentiate. So dHdt would be, we put the h right here, and then you got dHdt equals 500 secant squared over d theta dt. And the last step is to substitute what we do have so we can find dHdt. So when we solve the equation, you got 500 secant theta, which is pi over 4, times d theta dt, which is 0.14. So at the end,
stop when it's out loud.
So when everything's said and done, the HDT is 140 feet over minutes.